Discuss how the polarity of a molecule can be modified. Well, we're in the Arctic, or is it the Antarctic? I can't remember. These are my polar molecules, polar bears. It's a joke, polar molecules, polar bears. Now, polar molecules should dissolve in other polar molecules. Like dissolves like, if you remember your solubility rules. Oh, Dr. Atkinson. So my polar molecules should dissolve in water, because water is also polar. Oh, and there it goes. So why do we care? Well, if your blood is mostly water, then your blood is also therefore polar. So if I can make a molecule a bit more polar, it will dissolve in the blood a bit better and perhaps be more efficacious. It will work better. So let me put my polar molecule into the blood, and lo and behold, it will dissolve. Like dissolves like. So a polar molecule wants to dissolve in the blood. Oh, what's this? It's a snowball. Oh, I recognise that guy. I'm going to give it a good old chuck. Oh, didn't really work. Here's my non-polar molecule. Non-polar bear. It's a joke, you see. Well, I'm going to put my brains into this bathtub. Your brain has a barrier between it and the blood-brain barrier, and that only really allows non-polar molecules through. And the central nervous system is also non-polar. So non-polar molecules will tend to end up in the brain because they'll pass selectively through the blood-brain barrier, and also in the central nervous system. So if you want to affect those two regions of the body, you want to have non-polar medicines. I'm trying to dissolve the non-polar molecule into the brains. Oh, and there we go. Where did Dr. Atkinson go? I wonder. Oh, the non-polar bear looks angry. He's up a tree, I think, isn't he? The polar bear looks angry. Hold on, Dr. Atkinson, I'll come and rescue you. He looks a little distressed. Hold on a little longer. Oh dear. Oh dearie me. The IB wants you to know two examples, the first of which is aspirin. That has an ester grouping, functional group there, carboxylic acid, functional group, and that's a benzene or an aromatic functional group. So overall, this molecule is not very polar. The carboxylic acid may have a little polarity to it, but this isn't very polar, so it's not going to be very soluble in water. Like dissolves like, water's polar. This isn't very polar. They're probably not going to dissolve, these aspirin. So how can I increase its polarity? If I react it with sodium hydroxide, there's an acid-base reaction going on here. So the carboxylic acid, the hydrogen ion is going to drop off of the carboxylic acid. I'm showing some curly arrows to show electron pair movements. Now the H plus that's come off of the acid is going to react with the OH minus to make water, and the sodium plus ion is going to go up there. This is much more polar now, and it's called soluble aspirin. I reacted the carboxylic acid with a strong base and made it soluble. Fluoxetine, that's the correct pronunciation. Well, that lone pair of electrons there, that kind of looks like ammonia over there. Okay, this isn't very soluble either. Its solubility isn't enough for what they need it to do, which is dissolve into water, into the bloodstream, which is mainly water. Just highlighting the functional groups. Aromatic. And the final one isn't on the syllabus as one you have to learn, but that's an ether. Not an ester, an ether. So, once again, an acid-base reaction would solve our problem. That looks like and reacts reasonably similarly to ammonia. That's secondary amine, any amine. So the lone pair on the nitrogen is going to pull an H plus off of that hydrochloric acid, leaving a chloride ion behind. Now that's a dative covalent bond. 2 electrons are donated in the covalent bond from one species. It's also a Lewis base because it's an electron pair donor. which I suppose makes hydrochloric acid a Lewis acid. And a Bronsted-Lowry acid. Remember that? Seems so long ago. So let me tidy this up a bit. That's H2 plus now, because it took the H plus. The chloride ion is now attracted. Now it's very, very polar again. Just like the previous example. This is called a fluoxetine hydrochloride, which is known as Prozac, the antidepressant. It's much more soluble in water now, more soluble in the bloodstream.